I will start to introduce our next speaker with an exciting topic, which is sustainable use of AI by using AI. And Klaas Mertens from Equinix will talk about that. And Klaas, you joined Equinix in 2014 as a global solutions architect, and you are advising customers and prospects on solutions and services. The floor is yours.
Thank you. So welcome, and thank you for being here and listening. Today, actually, I want to talk about a little bit of the sustainability aspect of AI and how you can use AI to make AI more sustainable. But to do that, I need to talk first about a very, very mundane thing, which is, I hope this works now. Okay, let's see. Oops. Kein Problem. Then we wait for it, because you will all recognize what's happening here. And after the lunch, you hopefully all have used what I'll be showing you. There we go. And that's this one. I want to talk to you about water, and actually about something that probably every one of you uses every day. I don't know the real English word for it. In German, it's ein Einhebelhandmischer, so a hydraulic mixer, which does nothing else than mixing hot and cooled water. And fun fact about this is something that the mainland Europe had in advance of the UK, because when you ever have been to UK, you probably had two taps on the sink to wash your hands, one for cold, one for warm water. And there were even new inventions of this where they had two outlets, one for cold and one for hot water. So if you washed your hands, the left one was freezing, the right one was burning. That was because in the UK there was the rule that warm and cold water never be mixed, because they had heaters on the top of the houses where they had storage for warm water, and there could be bacteria and something else in there. So they said, no, cold running water needs to be separated from the hot water and never be mixed. And obviously our installation in Germany and the main of Europe was a little bit better, so we didn't have this problem. We had these mixers, so you could enjoy lukewarm water when washing your hands, which is a nice experience, I would say. But what has all of this to do with AI? What does water have to do with AI? Well, if you look at this, and you probably all have it in your household, what you probably don't have in your household is the kind of bigger version of that, which is nothing else than this Einhebelhandmischer, but which is a hydraulic mixer for hot and cold water in a data center. And my colleague here is standing in front just for the comparison of size. But this device, what you see here, is doing nothing else than the tap on your sink. It's mixing hot water from the roof, or cold water from the roof where the chillers are, with the hot water coming from the IT infrastructure in a data center where all of your AI models and inferencing is running and burning cycles of a lot of GPU processors or standard processors, or powering SSDs for storing all the data you want to analyze. And that is kind of the size that is needed only in a small portion of such a data center to cool all the IT infrastructure. And stuff. And I don't know, have any one of you ever visited such an AI data center? Anyone ever been in there? Raise of hands? No? One, two, okay. So at least you can get this idea. And now why we're talking about water, and now what does it have to do with sustainability? Well, when all of you are running your AI models, it, as I said, burns a lot of CPU cycles, burns a lot of power, and needs to be cooled. And this is done by water. So in the data center, there's cold air coming into the data center, cooling down the servers, then be collected, sent to the roof. There it is cooled down again via chillers out to the air, or meanwhile, there's also projects to heat houses with that for waste heat reusal. And then again, the cold water is pumped again into the data center to cool the servers. And obviously, this is a very important fact when you're running AI, and that is what we're talking about, either the PUE, the power usage efficiency, or also the WUE, the water usage efficiency. And that is a factor that is very well known in the data center world, but probably not very well known to people using AI or developing for AI, which says that the amount of power you need to put in to run your CPU cycles or power your SSDs for the data compared to the power you need to sustain the infrastructure, for example, running the pumps for the hot and cold water to actually cool down the infrastructure again. And the lesser this factor is, so the less power I need to put in addition to to the power for the servers, the more efficient my data center is. And there is researches here done on that, that the average PUE, so the power usage efficiency of data centers in Germany, has even come down from 2010 to 2020 from 1.98 to 1.63. And just to get this into perspective, a PUE of 1.98 means that if you want to run any infrastructure in a data center or in the cloud, and you're kind of using 1 kilowatt of power for that, then if you have a PUE of 1.98, you need to put another kilowatt of power in just to sustain the infrastructure, cool down the servers, run the pumps and everything. So there's a double use of energy if you're not that efficient. And actually, this has come down to 1.63. We at Equinix, we have kind of a number of 1.48 globally, and we're targeting 1.2. And there are some data centers who do excessive heat reusage and do excessive other topics who claim that they have a PUE of 0.98, so they're actually getting energy back by running the IT load, which is kind of debatable. But 1.2 is very, very efficient already. Now, to do that, there is a lot of stuff that data center providers do to make this more sustainable, to also allow that all of you can run more generative AI, train more large language models and stuff, which is all using a lot of energy, which is running in data centers, which is needing a lot of infrastructure to be connected. That's also very important. I mean, you run your language model learning not in your basement. You probably do it in the cloud, in the data center, not on your laptop on the desk. And there's a lot of things that has been done to make this more sustainable, emission control, waste heat reusal. We're putting green facades on our data centers, A, that they look nicer, and B, that there's some effect on the climate, and also a little bit helping the bees and insects in the general area. So that's the small things we do. But obviously, there's also bigger things that's been done. So using renewable energy, there's solar power on the roofs, which, honestly speaking, there is not enough roof space in such a data center to even bring like more than 2 or 3% of the actual used power into that. So just for a comparison, most of the data centers and most of the cloud infrastructure in Germany is concentrated in Frankfurt. There's a historic reason for that. Whoever is interested in why the cloud and the data centers are in Frankfurt, please hit me up afterwards and we'll gladly tell the story. But the power usage of all these data centers is meanwhile combined more or bigger than all the households in the general Frankfurt area. So the data centers are consuming more power than that. And that is also due not only to the fact that you're training AI models, but also to your Netflix streaming, Facebook usage, Amazon shopping, and all these kind of things. So there is a lot of efforts being done from the data center providers to make this more efficient. And one of these ideas I want to show you, because this is already giving a practical example of the use of AI to make AI more efficient. And that's a cooperation that we did with a startup from the University of Darmstadt. They're called Etalytics. And they are using an AI-trained model to control actually the heat pumps or the water pumps in the data center, which make sure that the infrastructure is cooled. So that's what I just explained was the hydraulic mixer, which mixes hot water from the data center and cold water from the roof to bring it on one temperature and then bring back to the data center. There's a lot of pumps, control valves, and stuff in there that can be controlled. So there is data coming, like from the outside, what's the temperature, what's the moisture in the air, what is probably the weather prediction for the next couple of hours, will it be raining, will there be clouds, all these kind of things. And then there's a lot of things that you can set. So the speed of the pumps running, how much water is pumped, the speed of the ventilators, of the fans on the roof, which cool the coolers. The coolers on the roof, they are also rained down with water, which evaporates and adds another cooling level to it. So you can control whether you run water, how much water you run, and all these kind of things. And there's also a lot of data being collected by this, like RPM of the pumps and temperature and so on. And this is calculated in such a model and controlled to make the use of the pumps and the fans and everything that can be controlled most efficient. And this is done actually with an AI-based cooling concept. So that's what the company Etalytics has done. They went into our actual data center and they developed a digital twin of the actual infrastructure. So they put all the set points and data into a digital twin of that and run this into a model. But what is also very important in this factor, they not only took this digital twin, let all the data run into the AI model and trained it on that to just learn by machine learning how the actual system would behave, but they also put it in a kind of a hybrid AI model. They enhanced this with actual physical knowledge. Because if you have a pump, if you have a fan, then you know from the construction and the laws of physics, how like the pump would behave, how the water will be cooled under certain circumstances and so on. And this knowledge, which not have been learned by the machine, has been put into this model as well to enhance the machine learned or AI model with more parameters and data to make it more efficient. And then this model, after being trained for a certain amount of time, has been put into effect and has been put in charge of controlling our air conditioning system. So the pumps and the fans and chillers and all this kind of things on the real side, feeding back into the digital twin. And obviously then there is a feedback loop in this mechanism. So new data is collected from the system, the model is retrained again, but also enhanced with new data from like newly built pumps or newly built chillers with the actual physical parameters in that. And when we switch this on, we actually immediately see an effect which brought our POE down by 0.025%, which doesn't sound much in this, but which can bring actually a very great effect. And you see it here in this chart. When we started to activate this optimizer and have it controlled our cooling system, then we in this data center, and that's only a small part of the estate that we have in Frankfurt, so it's like not even 10% of the completely installed IT load that we operate in Frankfurt, we had a reduction of 60 kilowatts of power all over time. So that is like a saving of 230 euro a day, but also 16 kilowatts of power that don't need to be used. And 60 kilowatts of power is something like 60 hair dryers or vacuum cleaners switched on at once, which we reduced just in this one data center. And this brought a lot of savings in here. And that's just by using this AI. And then once this is rolled out to more of the data centers and more of the cloud infrastructure, obviously there's a lot of saving. And it is only one system that needs to be run in such a data center, which can then bring much more energy efficient. And this project also has been awarded by a number of awards, the BMWI, so the Bundesministerium für Wissenschaft, Competition Digital Innovations Award, German Innovation Award for Climate and Environment, and a lot of other things. And it's a really direct application of AI services to the infrastructure that is needed for AI. And all of this is only possible by using a hybrid model of AI. Because if you just put the machine learning into the system, then probably it would learn that if you turn down one pump a couple of %, then it will result in a higher temperature. But you don't really know why. So because you just trained the machine learning model and it analyzes the pattern and does that. But if you enhance it with the additional information that you have from the physical behavior of the environment, then it really can bring a lot of value, and you also know what to happen and what will happen and where to optimize. And that is something what I also want to give a little bit of a food of thought for the last 6 minutes I have, is that if we think about this sustainability factor in AI, and if we think about like using what we all developing here for the greater good in enabling more efficient use of whatever technology and whatever industry. So we heard about like how AI can help us into a better analyzing company statements or attestations or something. But we always have to keep in mind how much energy we consume for that. How sustainable is it? Can we program in a way that it's more sustainable? And that's what I'm just showing you, is it's kind of showing the extent of the infrastructure that is needed for all these large language models. And there's a lot of discussion currently going on also in the politics about the Energy Efficiency Act and stuff like that, where there's a lot of reporting laws in. The PUE is legislated for data centers, and all of this is affecting the growth of AI. So I also want to kind of give you some food for thought. When you are developing AI models and programming something, then think about like what power consumption and what infrastructure needs are there when you're doing that. Because, and that is a study from Bitkom actually, we do want more digitalization. We want more AI models. All of us want to have a better federal government and processes when we go for prolonging our ID cards or driving licenses or something like that. So we need more digitalization, and digitalization itself can also help to achieve our climate goals. The more digitalization we have, the less processes we need that are more CO2 demanding. So we definitely need more digitalization. But if you do so, and if you think about like how the infrastructure is using this energy, we only see the tip of the iceberg. So what I'm talking about now, and what you probably all see when you see the papers or drive around, is just the big data centers and building that the big cloud providers are doing, and the hyperscalers or the co-location providers such as Equinix, such as we. But all the invisible infrastructure that is in server rooms, labs, in the construction buildings or something, that is not seen, it is not as efficient as I just talked about, and where there's no AI models to run the air condition, but just something stuck on the wall, which is just cooling the whole room maybe, and that is maybe not something where you want to run AI models. And it also has a commercial impact. So a lot of customers, they are overspending when they just use cloud infrastructure, because they just put whatever they think they need in the cloud, let it run, because it's just there and they can just use it. I mean, any one of you has an idea of the size, the physical size of a 1 terabyte of storage compared to 1 petabyte of storage? How that looks like? Well, 1 terabyte fits into like an SSD, which is like that small, right? When you put 1 petabyte of data into a data center to have it analyzed by AI, you're probably looking at a block like this, which is consuming like something between 10 to 15 kilowatts of power. That's the difference that you have in the conversation, and that's also the difference you need to think about when you're putting your large language models. And that brings us to the fact that, and I'm skipping a little bit over here, that we probably need to think about a more hybrid model as well when developing our AI models. Not just think, okay, we put a lot of data into the cloud and just let the AI models run, but we might want to think about a hybrid platform where we can decide, well, I have data somewhere at some other customer or vendor, and I don't need to copy over that data to my infrastructure, but I maybe find a way to use it directly where it already is without needing more infrastructure to train my model. But I can maybe reuse what this partner or holder of the data has already done. And this is just an example of such a hybrid infrastructure where you can put multiple clouds to use, see where the data is stored actually, so in which data center and in which infrastructure, and make use of the data and of the infrastructure that is already there without needing to copy it over, install more GPUs and consume even more power, and make us compelled to build more of these hydraulic water mixers into the data center to just cool down your infrastructure. So I want to stop there to just have a little bit time for questions if there's any. Obviously, I'll also be here afterwards to answer any more questions. Who has questions to data centers, cloud usage, how everything works in this together. Also like how the internet works and how much power is consumed there and how we can do this more efficient. But I just want to maybe give some ideas that when you turn on the tap afterwards in your house and get some water out, and also think about the water that is consumed by all the large language models, cloud infrastructures and AI models, and maybe have a little bit thought of the sustainability effects of this. And yeah, with that, I'll be at the end. Thank you very much for your information. I'm here for more questions.
Yes, thank you. And we have time for one short question if there is one. Otherwise, perfect timing and a lot of room for more discussions outside than later on.
Thank you.
Thank you very much.
Thank you.